Alright, so here in 8.5, we're going to be looking at solving logarithm equations. You'll see all of these have logarithms in them, whereas in part A of this section, we looked at solving exponentials. Now, we're going to look at a couple of different situations here. The first one is if there's only one logarithm in your problem. If there's one logarithm in your problem, just change forms. So change from logarithm form to exponential form. You should be able to solve once you do that. So I have 3 to the second equals x. Now, of course, I gave you all a simple one first, but you can go through and you can actually solve. So x is 9. Now, you're going to notice on a lot of these, you don't need your calculator unless it's because the numbers are big or something. It's not the same as the exponential ones where the numbers are really messy and you need your calculator. Okay, so I'm going to do the same thing here. I'm going to change form. So 5 to the third equals x plus 2. And then go through and solve. So this is 5 to the third, 5 times 5 times 5. And then I'll subtract the 2. So you get the idea here. So 2 to the fifth equals all of this stuff. So 2 to the fifth is 32. 2 times 2 times 2, 5 times. And then I'm going to go through and solve. So subtract the 1 and divide by the 4. So 31 over 4. I guess I should circle that one. So change forms, solve whatever you have once you change forms. Now the second ones we're going to look at is if there's more than one logarithm in your problem. So you'll see here there are 2 logarithms here. There's also 2 logarithms. They're on different sides of the equal sign. But if you've got more than one logarithm, what you want to go through and do is condense. Now condense using the product rule, quotient rule, all of those. I think that was in 8.4. Make sure to condense first, and then you'll change forms. Okay? Now the condensing is basically to get it down to where you only have one logarithm. Then you're back to these problems over here. Now they're probably going to be more complicated. So just a heads up on that. They're going to be more complicated, but this is what you're going to do. Okay, so when I'm looking at this, the first thing I'm going to do is condense those. So since it's addition between them, I'm going to condense them to multiplication. Now see how I condensed those? I used my product rule. Because there's 2 logarithms added together, I can combine the stuff inside with multiplication. And then I'm going to go ahead and FOIL those together. So I have first, outside, inside, and last. And then I've got, maybe I should put parentheses around that. I've only got one logarithm now, so I'm going to change forms. So 2 to the third equals all of that stuff. And I'll go through and solve. Now, I'm afraid I'm going to run out of space, so 2 to the third is really 8. And then I'll go through and solve. So I'm going to bring the 8 over here, get everything on one side of the equal sign so that I can factor or quadratic formula this. So x minus 6, x plus 3, x is 6, and negative 3. Now, on these, make sure that you are checking them, because remember how when we had a negative number inside our logarithm, we got like a error in the calculator. I told you it doesn't work. You just can't have that value. Now see how if that negative 3 were right in here, see how we would get a negative 1? You need to go back and check those, make sure that they work. If they make you have a negative number inside your logarithm, you got to throw it out. Now 6 is okay because 6 plus 2 is 8, 6 minus 5 is 1, so I only have one answer. Now this kind right here, this is going to be your hard kind, so you want to make sure that you're thinking about these. Okay, now I want y'all to think about this one before we go through and we do any of the stuff like we did here, because this one does have 2 logarithms, but I think it's a little bit of a trick question. The reason I think it's a little bit of a trick question is because of this logarithm right here. I'm going to go through and I'm going to rewrite that 9 as 3 to the second power. Now the reason I'm going to rewrite 9 that way is so that I have one of my shortcuts. Y'all remember the shortcuts? If these match up, the whole thing simplifies down to the exponent. And then I just have my 2 here. See how I was able to get rid of that logarithm? Look at that first. If you can get rid of the logarithm, it's going to make your problem a whole lot easier. Now, I one time, because I just like to do weird things, I'm a math teacher, I one time went through and solved this leaving this logarithm as a logarithm and doing all the condensing stuff. It was a pain to solve. It took me as long as this one, if not longer, and it was more complicated. If you can simplify it down first using a shortcut, do that. You'll be glad you did. Now, once I've got it kind of combined down to just one logarithm, then I'll change forms. Again, I'm running out of space. This is 9. When I subtract my 4 over, I'll get 5 is my x. Now, I do want to just double check that it doesn't make, oops, I don't know what I just did there. I do want to just double check that it doesn't make my whole thing negative inside here. It doesn't, so 5's a good answer. Okay, now the last thing I want to mention here, and we won't, I don't know why I have those problems again, we won't necessarily look at all of these, but I just want you to remember that if you've got a natural log, remember natural log is base e. So you're still going to change forms, but remember this is like it's a base e here, here, here. So remember that when you change forms. Now these, different from the ones before, you probably will need your calculator because the answers can be kind of messy. There might be an exception or two here, but generally you will need your calculator. Now I'm going to really do the same thing. I'm going to change forms. So e to the 5.367 equals x, and I can put that in my calculator and see what I have. Let me get my calculator real quick. I don't have it with me at the moment. Alright, so I'm going to put that in my calculator, and I will get 214.2 equals x. Okay, now I just want to mention something on this one before we go through and change forms. Here's what I want to mention. If you have a square root with logarithms, it might be easier, almost always is easier, to rewrite it in fraction exponent form. Now, the reason I like to rewrite it in fraction exponent form is so that I can pull it to the front. I can use the power rule and pull that to the front. Now y'all remember we were condensing a minute ago. This is the power rule. And then I'll go through and actually get rid of that 1/2. So natural log of x plus 4 equals 2, and then I can change forms. So e to the second equals x plus 4. And then I'm going to subtract 4, then I'll put it all in my calculator. So then I want to go through and see what e to the second minus 4 is. And it's 3.4. I had to round a little bit, but about 3.4. Okay, and this last one, we're not going to actually do the whole thing, but I just want to mention this. We kind of had this same thing in this middle problem here. But if you've got a number out front, get rid of that first. It'll make your problem easier to deal with. So if you've got something other than your, in our case, natural log, but any log to some number, go ahead and get rid of that if you can. then it'll make it easier to change forms and solve from there. Okay, and I'm not going to put that in my calculator. Y'all can do that on your own. But you'll end up with, I actually have it in my notes. Okay, maybe I don't have it in my notes. So I'll let you put that in your calculator and see what you end up with. All right, so this is 8.5b.